Hi everyone, now in this question, how do we even find the distance traveled in the fourth second? Now some students may simply substitute t equals to 4 into this equation here, but that's not correct. So let's see how this can be done properly. Now stick around to the end of the video where I'll also show you the difference between part B and C. So let's start off first with finding the time at which the particle is instantaneously at rest. Now this means that the velocity is equals to 0. Now to get the velocity equation, simply differentiate the displacement equation once, which gives us 8 minus 2t squared. By equating v equals to 0 and solving this quadratic equation using the difference of squares, t is equals to 2. Now you can reject the negative answer as time should be a positive value. So there you have it. The particle is instantaneously at rest at t equals to 2 seconds. Now let's move on to part B. Now we first need to understand this. To get the distance traveled in the fourth second, you need to find the distance traveled between the third and the fourth second. So let's illustrate this using a diagram. Now I choose to find the displacement when t is equals to 2 because this is a very important milestone. Whenever you see the time at which v is equals to 0, always show it on the diagram because this is where the particle will change its direction. So at t is equals to 2, s is equals to 10 2/3 meters. Now at t is equals to 3 seconds, the displacement will be equals to 6 meters. And when t is equals to 4, the displacement is negative 10 2/3. Now with this information, the distance traveled in the fourth second is basically we are taking the absolute value, which is 10 2/3 minus 6, and is equals to 4 2/3 meters. Now similarly, if the question wants you to find the distance traveled in the first second, for example, it will be between t equals to 1 and t equals to 0. Now the distance traveled in the second second, for example, will be the distance between t equals to 2 and t equals to 1, so on and so forth. Now before we move on to the next part, do remember to subscribe to this channel to see more valuable content such as this. Now in part C, we need to find the total distance traveled in the first 4 seconds. Now this is where our diagram comes in really handy. It's basically the blue pathway taken by the particle in the first 4 seconds that you see over here. Now but be very careful, this has a value of 10 2/3 as it is measured as a displacement from point O. Thus, breaking up the pathways, the total distance covered is simply 10 2/3 and 2 of these sections over here, which is coincidentally 10 2/3 meters as well. Adding them up together, this will give us a value of 32 meters. So this is the difference over here between part B and C. For part B, we are actually finding just the portion of the distance traveled, specifically in the fourth second, while in part C, we are finding the coverage of the entire pathway in 4 seconds. Now I do hope you have learned something from this video. Do leave your questions or any thoughts in the comments box below, and thank you so much for watching.